Today's video has been brought to you by Baltic Networks, affordable wireless solutions, and Ignitenet, fire up your network. We'd like to thank Baltic Networks and Ignitenet for sponsoring the Ignitenet Terragraph video series. Thanks guys for making these videos possible.
Hello folks, how are you doing today? Fuck yeah. Today's video sponsor is actually Baltic Networks, so I'm going to try not to be too crude because they don't have any kind of effect over what I say, so their opinions don't reflect what I say and do in my videos, just in case I say and do something idiotic, because, you know, I'm notorious for that. But anyway, thank you Baltic Networks for sending us some awesome hardware to do some teardown time. So today's teardown is going to be a Terragraph station. I got ya. I'm sure you guys thought that I was going to, like, you know, pull out the actual Terragraph access point, but no, we're going to build to that. We're going to do a station today, and then we'll do a teardown of the AP, okay? Because believe it or not, there's a lot of shit that goes into these motherfuckers. So I actually had to, I had to do quite a bit of research, in fact, which you'll see by the stacks of paper that will be included in this video, which I'm taking a page from Big Clive's book, because, you know, I love Big Clive and Photon and, you know, Electro Boom and all them. And I've actually blown up some images of some chips and whatnot so that I might be able to get some good information for you guys, because I want to be as thorough as possible to almost an obnoxious degree here for this particular content. Okay, so let's open this. Oh, I don't get to use my machete. Well, I guess I can put that back in. It will not taste blood today. Well, it might. No blood today. Here we go. So let's tear this thing apart. And by the way, I'm just joking. That machete is about as sharp as a butter knife. I mean, like, actually, that's the funny part about it, because it's a prop. It's meant for opening boxes, you know, because that seems to be a weird thing that electronics YouTubers do. They like to, like, open things with big, scary knives. Like, EEV Blog's got, like, he got big old knife that Crocodile Dundee uses, you know? So, anyway, let's open this thing up. So, here is the station. Here's the cool-ass station, folks. This is the station. This is the 60 gigahertz station for the Ignitenet Terragraph equipment from Ignitenet. So, and it comes in the box with, I think I already did an unboxing, but it comes in the box with 2 glands, which is awesome. Okay, it comes with a filler, in case you don't want to use both glands. Glands. There's something else called glands. Okay, it also comes with a 48 volt 0.5 amp PoE, and this is 2 pair power. What else does it come with? Nice power cord. Actually, that's a sexy power cord. Some pipe clamps, and that's pretty much it. Alright, so let's put all that back in the box now, because I'm going to do the teardown. Now, we've already actually torn one apart. So, what I did was, because I, you know, not to destroy the movie magic here, but realistically, do you guys want to watch me pull a bunch of fucking screws out of this thing? Probably not. You want me to get to the point, and I've been told that my videos are too long, which is why I'm holding it right now, because I've got to piss like a racehorse, and I figured that at the very least, if I'm dying here because I need to urinate and my kidneys start to ache, then I'm going to be able to keep the video a little bit shorter than I normally would, while still squeezing all the content in, because I got a pee so bad. So let's take a look at this bad boy. Yes! Oh, I'm gonna get shredded for slamming it, but realistically, don't worry, this thing's fine. So I've already got apart. Some of the heat, the coupling gel is off of it. Or, no, that must be from another thing. Anyway, okay, so let's take a look first of all at the thermal coupling. So we've got all these extrusions, I guess all these builds on the housing, on the chassis, which are helping us to bind the rear of the housing to the chipsets here to keep them cool so that they don't overheat, of course, right? Very well built that way. We've got some grounding pads on here as well that are actually bonding the chassis, the aluminum chassis here, to the Ethernet ports at the back here to ensure that we've got proper grounding across surfaces, which is awesome because there's no ground lug on this, which is perfectly fine. So yeah, this makes sure that if you're using shielded cable, this is going to be really good for that. Let's see here. So if we look at this guy now, you're going to notice, by the way, how do I look on camera? Are you seeing a lot of forehead? Because I'm playing with a new camera setup. Yeah, so we've got these pads on here, specifically for conducting heat from here's the RAM here, okay? We've got the RF chipset right here. Back here is the Ethernet chipset, and then right here is the voltage regulator, and right there is the hard drive, and then that is the sexy little monster that powers this thing. Ha ha ha. Yes. And I actually had to clean it up because I had a lot of thermal gunk on it. So anyway, so let's tear a little bit further. Where are my tearing tools? I'm good. Over here. Alright, so let's use a pair of tweezers inappropriately. And I'm going to get right underneath this. This is nice because they didn't actually solder the caps onto this. I can actually like pop them off if I actually put some effort into it. There we go. So there's that. So notice that there's thermal goop on top, and there's also thermal goop on top of the network chip here. All right. So there's a network chip buried underneath there. So this is actually really well thought out because if you really think about it, the network chip is actually canned on the board to protect it from RF. So that's going to ensure that we're going to have a really good connection. I think that's because this device here is actually capable of around a gigabit per second. I think it's actually 2.5 at full, and it's 1 gig half duplex. You can look at the spec sheet anyway. So this guy is capable of pushing a lot of bits, pushing a lot of packets. You're a packet pusher. All right, let's take this guy off now. I can get you apart, and I'm going to take this little bit of thermal gel off, and I'm going to push this to the side. And now I'm going to undo this little power connector here for the antenna array. And I'm going to fold this little piece of metal here just a wee bit so I can get the power cable free. I'm going to get the power cable off of there. And then I believe that there is an RF connector on here, which I have just unplugged. Perfect. So now let's take a look underneath, and then we'll go over these chips, okay? We'll go over the chips one by one. So, and by the way, you want to see something really crazy? All of this housing here, all of this, okay? You want to see the antenna? This here is the antenna for the whole thing. It is in the top corner of this unit. Look at that. That is the beamforming array here. And it's got some power going to it. I'm not exactly sure why. There's a chip here. This looks like the actual amplifier right there. That would be why, because the amplification is done on here. This is the RF feed coming in. I believe that this is actually 4x4 MIMO. I'm not entirely sure. I can look at the specs of the station as well. I'll give you guys links, obviously, so you guys can do some more research on it. I mainly looked at the actual core. Once we actually start getting into the software aspect of these this system, then I'll start getting into the actual hardware specs on it. But right now we're doing Teardown, so let's focus on Teardown. All right, and so yeah, that's a really cool little, let me see if I'll bring it up closer so you guys can see it better. Focus. Can I focus on that? There we go. So that's the antenna array. It's like a ceramic antenna array. You usually see antenna arrays like this in GPS's Bluetooth devices. It's a big ceramic one, and it looks like each one of these little doped surfaces are actually elements with I'm not even sure. This is more of like a Tassos or an Andre Werner, kind of question. So 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 elements in each array, and we've got 1, 2, 3, 4, 5, 6, 7, 8. 8 arrays. So did I say 8? So that'll be 64 individual elements, and I'm not sure what these guys on the side here are. If those are actually elements as well. 1, 2, 3, 4, 5, 7, 8, 9. Those could be ground on the sides or whatnot. I'm not entirely sure, but anyway. So now if we look at the back of this thing, you can see the RF input here. All right, so the RF comes in. RF come in, and we've got power going to this little tiny chip here, which to me looks like a chain amplifier that goes in there, and that's like in the RF chain, right? And so we've got RF coming in here. It goes out here. Let's throw this goop off of here. So then this enters the array here. That's where the RF signal comes in. That must be for the beam steering right there, I'll bet you, or something. That's why there's power going through. There's a bunch of caps here to support it as well, and I'm sure scrub the signal. We've got, it looks like some kind of a little tuning trim right here. Let's see if I can get this focused again. Maybe if I brought it down. You know what I'm going to do? Actually, I'm going to zoom in a bit. There we go. If I zoom in and then I hit the focus on here, that'll lock the focus for me. All right, so let's take a look at this guy. Yeah, this is pretty neat, eh? So we got this chip here. I'm not sure what it is. It's a U300 is the marker on it, and then we've got a bunch of caps. And then we've got this little squiggle here, which is probably some kind of a waveguide or a bandpass, like some type of a filter, right? There's the antenna right there. That is really neat, eh? Isn't that cool? So that's that portion there. Now let's take a look at the board a little bit more. So now that I'm super zoomed in, here we go. Yeah, I'm looking over my screen. I don't have my screen right there yet. I'm working on fixing that up, so I'm looking off to the side. So we've got like lots of neat components. So this is the brains of the unit. This is a SoC. This is the Qualcomm IPQ6010, and I've got the spec sheet for it right here. See, yeah, here we go. I got this idea from another channel. From Big Clive, of course. BigClive.com. Best YouTuber there is. Him and Photonic Induction and Electric Boom. Actually, I can't say best YouTuber. I'm not going to go down that rabbit hole. They're all awesome. Equally awesome is what I should say. Okay, so let's see here. So here's the actual chip. There it is blowing up. Okay. So let's take a look at the specs and capabilities on this thing. So this is a 6010, right? So this is the Qualcomm Ethos. The Qualcomm Ethos technologies provide customer with industry-leading power and solution size to enable fast or gigabit Ethernet connectivity and networking equipment, consumer electronics, and computing platforms. Qualcomm physical controller and switch solutions support the IEEE 802.3AZ standard for energy efficient Ethernet to extend battery charges on computer platforms and deliver power efficiencies in networking equipment. Qualcomm also enables incremental power saving techniques to offer our customers the very lowest power Ethernet in the industry today. The animals. Okay. Let's get away from that. Boring. You guys don't want boring. I know you guys, because you guys always whine when I get into the boring stuff. But there's a lot of people out there that want to know the specs and the information on here. So let's see if I can zoom it again, or not zoom, but focus. All right. So we're looking at the. This is a 6010. So it's a quad. A531.8 gigahertz processor. 1 gigabyte supports up to 3 gigabytes, 16 or 32-bit DDR at 2133 MTS. NOR flash is 8 megs, NAND is 128, supports up to 1 gig. So I'll bet you these guys here are a couple of 64 megabit or megabyte chips. Brain fart, sorry, EEPROM 128 kilobits. All right, so NPU, 112 thread network processing unit. NPU UBI32 at 1.5 gigabits or gigahertz. DSP, digital signal processor. High performance hexagon DSP with vector extensions, 800 through 1 gigahertz. Packet acceleration. Ooh. Packet processing engine, PPE, for standard 5-tuple routing, or that should be tunnel, not tuple, I'm sure. 5-tuple routing, bridging of IPv4 and IPv6 packets with ingress capacity of 37.5 megapackets per second, and egress capacity of up to 10 megapackets per second per port. That's pretty sexy. Now for the WLAN interfaces. Onboard 2x2, 2.4 gigahertz 802.11 BGN-AX. BGN-AX, cool. Max 28 dBm per chain. Onboard 2x2 5 gigahertz 802.11 ANAC-AX. Max 26 dBm per chain. 2412 megahertz through 2448. Blah blah blah. Okay, so the maximum physical rates on here: 5 gig is 840. 2.4 is 400. I should put this back in the frame so you guys can see something pretty to look at. We're looking at that sexy thing. We're looking at that sexy mother. Okay, SU MIMO to SS1 user. That's 2.4 gigahertz. Let's see here. DL-MU MIMO to SS 2 users. Whatever. Integrated Ethernet physical 5 by gigabit Ethernet. Its operating voltage is 6 through 16 volts. Okay. Supported operating systems are OpenWRT 1505, kernel 4.4. It's ROHS compliant. This thing will run from -20 to 70 C, which is pretty standard for network equipment. And at storage, it'll do -40 to 90 C, which is pretty cool, right? So that's pretty good. Let's see here. Supports secure boot. Support for LDPC in both transmit and receive for increased wireless coverage. Supports digital pre-distortion, which reduces power consumption and improves band edge performances. Power LED and GPIO. Who cares? Let's see here. So this is a cool little chip. This is like an anything chip. It's really kind of neat. Yeah, it supports all that stuff too. There. It supports all that stuff. We're looking at this chip right here. This is the Qualcomm. Qualcomm, not Qualcomm. God, I could never say it properly when the bloody things first came on the market even. It's like one more little pretty peek at it. Ooh, isn't that sexy? Look at that sexy thing. Yeah, that's that. That is a cool looking chip, eh? The IPQ6010. That's the brains inside of this thing. That's what runs this. Okay, so let's move this over now. Let's take a look at another little aspect of this. It's really, really cool. Let's take a look at the Ethernet chip for just 2 seconds. Oh yeah, I'm being a tease because I'm building to the wireless chipset. Huh. So this is a QCA8072. Big boy right there. It's in a can. Yeah, it's a standard gigabit Ethernet interface, blah, blah, blah. It supports, let's see here, supports 3 working modes with power on strapping configuration, 2 gigabit to Ethernet ports, 1 gigabit to ePort combo. Yeah, so it's basically, it's just a switch / Ethernet interface. So both these ports are using that one Ethernet interface, which then comes back into the SoC right there to connect it all up. Not much to look at here. Yeah, it's really, really hard to read that. So like that's why I wrote in green on it. Yeah, balls. Okay, let's take a look at the next chip. All right, I think this is the beefy one. No, I'm gonna do the beefy one last. I want to do the RF chip last because you know I'm just like that troll. Okay, so here is the power supply for it. All right, so that would be this little guy right here. You know, clearly the one that's got. Let's see here. Clearly the one that's surrounded by inductors and capacitors. That's gotta be the power supply right there. There's a lot of neat stuff on the back too. Look at the power protection in this thing. It's got a lot of power handling, a lot of caps, a lot of diodes, a lot of protection. It's actually very well built. It's even got a full bridge rectifier. Electro boom. All right, so let's take a look at this now. So there's our chip. So it is basically it's a let's see here, buck converter. So it takes in power, 48 volts in this case, and it dumps it down to 4.5 amps, 2.5 amps, 3.4 amps, 4.2 amps, and it does 0.6 to 2.1875 volts. 2.8 to 5.5 volts. All right, so that would be some of the operating voltages here. Let's see here. I don't really need to delve into this thing too much, but if you really want, you can pause right here for a second. I'll leave this up for a second so that you can read it. That's right, pause if you want to take a look at that, and I will scroll up a little bit here. There you go. If you want to take a longer look at that sheet, you can pause it, because I am getting itchy. I want to take a look at this 60 gigahertz chipset here, okay? There we go. So, what is the powerhouse RF chip underneath this little can here that connects the Terragraph stuff? Let us find out. So let's see here. So I'm just going to get this can off. There we go. So I got the can off. Look at how tiny that thing is. So that's the 60 gigahertz chip right there. It is a Qualcomm. So everything in here is Qualcomm Atheros. QCA 6438. That is the chip under the can here that handles the 60 gig radio. And it is cool. Yeah, man. And then there's another one of these. Actually, here's the interesting part is that we've got like a little... it looks like an RF amplifier right down here. And then we've also got a similar amplifier, or it could be a multiplexer as well. I don't know because it's scrubbed, and its board indication is U, and I think U is for transistor. I can't remember offhand because I'm stupid. No, Q is transistor. U is a voltage regulator, I think. Could it be a voltage regulator? Let's check. What can I verify that against? Yeah, U is a voltage regulator, so that's a U, and that's a U right there. Ooh, this is getting really interesting. So now let's put this board aside because God knows you can already see what I'm getting at here. So let's take a look what this thing's capable of. I am so sorry about the small print here. So this is the QCA 6438, so we're going to find this in the list here at the bottom. It's PCI Express 802.11ay, 4x4 60 gigahertz, 802.11ay, 18.5 gigabits per second physical, targeted infrastructure and fixed wireless access. There's zero, this is cool, zero adapters, zero E-systems, external links, blah, okay? But it's 4x4 MIMO. MIMO. Is it MIMO? MIMO, MIMO. Alright, let's see here. Now let's take a look at this. Alright, so here's some specs on it, okay? Here's the FCC ID, blah, blah, blah. So, AY9600 802.11ADAY, which is contradictory because this sheet right here says that it is AY only, not ADAY, so that could also just be a different reference point. 4x4 MIMO. Let's see here. Up to 5 gigabits per second. In AY, which this is the AY, so up to 5 gigabits per second in AY. Cool. It does 5 gig and 60 gig. That's cool. I'll leave this sheet out for 1 second here. I'm going to zoom out a little bit so you guys can see these sheets a little bit better, okay? Here we go. And then this way you guys can pause. Yes, my screen's over there still. I don't have one here behind the camera yet. Constantly working on things. Thanks, Patreons, for that, by the way. You guys cover all this shit. All right, so let's take a look at this. I'm going to refocus again just to make sure that it's in sharply. So if you want, pause on this sheet. I'm going to go to the next one. This should be good. Let's take a look at the next page. There's some more boring stuff. All day, boring shit. There's a Windows driver here for it. Hacking time. Again, pause on any of the sheets you want to look at. Why am I even doing it this way? I'm not even thinking. Let's take all this shit and just put it over here like so. Okay, so there's another one. If you want to pause there. 60, it is the 6438, so this page is not actually relevant to what we're talking about. It's on here. There's the chips, 802.11 adapter. Oh my god, this shirt is killing me. It's like 30 degrees outside with a humidex of like, I have 37. Oh, woof. Okay, this is like bleeding edge chip, by the way. Here we go. And, oh, here's the vulnerability stats sheet for it. So, number of vulnerabilities, it looks like there's, as of 2021, 8 total. No DOS, no code execution. There's 12.5% are overflows. So it looks like there's an overflow vulnerability to this chipset. That's it. And it's only 12%, 12.5% if I'm reading this correctly. Warning, vulnerabilities will publish dates before 1999. They're not included in this table, blah, blah. All right, well, I'm assuming that it's going to be pretty damn secure because the whole system is IPv6 with IPv4 tunneling, okay? So that's how this thing works, okay? So now we've got this here. So this is the 400 platform, the networking platform, which is, this is more specifically to the, okay, so this is for AX. So this is actually the wrong data sheet. God damn it. Yep, we don't want that one. Oh, that's right. It's because this one covered one of the other chips that was on here. I downloaded it and printed it, which was stupid, but it can go in the recycling bin. All right, and it's more with the 400 platform. Okay, that's pretty much it to go over the chips themselves, all right? We will be doing software overview as we start going through the actual hardware itself, but let's roll the hardware around again for a little bit in our hands. Our greasy, cheese-covered, little filthy IT fingers. Fuck, this is a nice wine. Today's wine. No, put it on that camera. The Dreaming Tree. Yes, I really like that. All right, so let me zoom in so we can like look around this sexy little monster. He's a sexy bird. So once again, we've got our, let's see here, we've got our primary Ethernet port. Where is it? Here we go. So
This is the uplink and PoE. This is LAN. Okay, so this one here, it looks like it might actually have PoE pass-through on it as well. It looks like you might also be able to, you may be able to power it from both sides. Let's see here, hard drive. There's some power supplies here for the RAM and CPU. See, that's over here. Let's see here. We've got the inductors going over here. This is to clean things up, going over to the network chipset. So you can see both these ports come to this network chip here, which then feed out into the bus input on here for the Ethernet. So this is actually a switch chip, so that both these ports are actually switched on the same interface coming into the sock here. We've got our voltage regulator there, which can actually handle a surprising amount of current for how tiny it is, which is probably why it's got all of these friggin' pads on it, right? Okay. So then we come up here. Let's see here. A lot of the RAM's all direct bus, of course, to the sock. We've got our LEDs right here. Our power supply for the antenna. Which, where did I put that teeny tiny little antenna? That thing needs some showtime too. Let's see here. And it looks like something else can go over here. Looks like either a couple of. It's a connector. There's 2 connectors that can go on there. Oh my God! You know what that is? That's a PCI Express connector. Look at that. See how the pins are divided? So you've got your first set of pins for the small portion of the socket, and then that's the second set of pins. So it looks like this was originally designed to be a snap-in board with the 60 gigahertz radio on it. But then they changed their mind and their design, and instead surface mounted the actual chip. So they put the entire 60 gigahertz chipset on board instead of making it a card. That's really fucking cool. Alright, so we've got our 60 gigahertz here. Here's our RF connector, our micro UHF, and our power to feed the antenna. Flipping it over, let's take a look at this guy now. So we've got a bunch of Schottky diodes on here. Another full bridge rectifier, inductors, caps, just to clean everything up. This looks like, so we've got our, where is that? Hold on a second, there's no transformers on here. There's no coupling transformers. Unless it's those, not those. Okay, I'm not seeing any coupling transformers on here. I think that we're using opto-isolators from the Ethernet ports. Maybe? No. Q is transistor. And the lines from here come into these little transistor type chippies right here, and then they go into some capacitors and then into the Ethernet. So yeah, it's not your standard inductive transformers, like any kind of like coupling transformers on here. It's actually some little solid state junk going in. I say junk, I'm saying that because I'm being dramatic. High current traces on here, that's cool. Let's see here. So what is this little guy here doing? This looks like a ROM. Be the boot ROM right there, and there is a ton. So it looks like, yeah, the RAM's got tons of shit going to it. But then we've got PCI Express lanes going from the chipset. It looks like they're buried in one of the internal layers on this board, and it looks like it could be a 7-layer board, maybe. Usually the board has a marking on the edge that'll tell you how many layers are in it. But I'm not specifically seeing anything on here about the layers. It'll be right around here. Yeah, so all the communications lanes between the... Oh, nope, there it is. Okay, so they're all coming in over here. So that's the revision work right there. Yeah, it's all within the internal layers that are connecting the sock back over to the radio chipset. And then, of course, we've got our little TVS diodes right here. Do we? No, because these lanes come in directly to these chips here, and then into these resistors, and then straight into the Ethernet chip. So over here we've got, those are usually for protection on the Ethernet. Oh wait, no, so those are not TVS diodes. Okay. Huh, that's pretty cool. So it's kind of a different design. It's actually definitely the bleeding edge. This is a brand new type of design for an RF device. Now, of course, this is something which I'm really sticky about, and I've been pissy about it before. If you look at the inductors here, thank you. You guys are brilliant. You glued the inductors to the board as well as soldering them. You used, it looks like a very nice epoxy. This radio is a sacrificial lamb. Yeah, that's an epoxy. It's not silicone or anything. So this thing will take a little bit of abuse. It's, yeah, because like if something's a piece of crap, typically you'll find heavier components like inductors won't have anything gluing them. They'll be soldered down and that's it. But the problem is that if they're rattled around enough, or if there's a poor solder joint, the actual component can pop off the board. And if it pops off the board, you have to send it to a shop to get it repaired. And how many people out there know shops other than us that actually do board repair on this stuff? And by the way, yes, I have been trying to get Thomas to actually let me film some of his work on repairing equipment so that you guys can see it, but it is kind of part of our bread and butter, so rightfully so, he's a little nervous about us putting that stuff out there, but eventually we're going to figure that out, okay? Yeah, so I don't know what else I can say about this thing. It's pretty cool, right? So here's the antenna. That is the whole antenna right there. This whole surface here is basically just the front of the radio, so if I was to pop this guy back in here like so, there's the radio. You know what I should do? I should actually put this on a board and cover it in epoxy or something, which would be so fucking cool. And then this little antenna here, the main antenna for this whole device, is just right here.
That's it. That's it. That's the tiny little radio, or antenna, sorry. And it is right here. So when you're looking at this whole unit, that's all that there is to it for antenna. That's it. Isn't that cool, eh? I'm trying to film, guys. I love all of you, but yeah. I'm trying to get some more equipment for you guys, actually. I've been talking to a few of you guys on the Wisp Talk groups about bringing in some Adtran, Cisco, and Juniper equipment so I can start doing teardowns and tutorials on how to program them. Because I know that you guys have been begging for Cisco microtik integration, so that stuff's coming, don't worry. We're working on it. I'm working hard to get more good content out there and answer all the questions you guys have given me in the Patreon and on the Ms.Fixit Facebook page. So, all right, so I don't know what else there is for me to say about this thing. They're very simple. They're very elegant in their design. They're very clean. I would say that this is fucking well built. I like it. This is a very well built device. Look at that fucking capacitor though, man. Look at that sexy. It's so big. So, wine time. I'm not a technophile. All right. Yeah, that's all there is to it. There you go, guys. So I hope you enjoyed the teardown. Yes, the software side and the testing, because there's actually going to be there's going to be more than 4 videos in this series on the Terragraph equipment. I'm going to exhaust the shit out of this. The next teardown is going to be for the node, the master. And then after that's done, we're going to cover the software integration on both of them so we can actually I'm going to teach you guys how to connect the stations to the masters. That'll be one entire video on its own. And then I've got another video coming up where we're actually going to take these things out and field test them. And we'll be field testing them with these cool ass iPerf 3 targets that I created, which I did another video on when I built these. 12 volts in for my battery pack on this guy here. Actually, you know what? Let me move this. This is kind of a sneak preview because, or maybe it's not, because I think that video will be up before this one. If I can get this video edited, if you can get this done before we get to this video, I'm going to do the Terragraph teardown first before I do this. So this will actually be a preview. So what we have here is a NanoPi Neo 3. This is running iPerf 3 on it so that it can be a target for testing the capabilities of the RF link. Cool, eh? And then this little boost converter gives us 48 volt PoE to power a station or power the actual access point itself. Or if that's not enough, I can actually unplug this and I can put a terminal on here and connect this to the DC input on the master. Okay, so there you go. We've got some really cool stuff coming up on this Terragraph thing. So don't forget to like and subscribe. Tell your friends, please. I really want to build the channel up. I'd love to actually be able to do YouTube full time and be able to bring you guys way cooler stuff than just teardowns and tutorials. Which, by the way, there might be a really cool video coming up that's not going to be the usual that you guys expect, but it'll be very technical and fascinating for you guys who have that thirst for it. Yep, and all you Patreons, thank you guys out there. If it wasn't for you guys, I wouldn't have the equipment that I've been getting to improve the channel and or feed myself or pay Yuya for his awesome editing abilities. Yeah, that's all there is to it, I guess. And thanks again, Baltic Networks. You guys are awesome. Baltic, see? The shirt seems a little bit big on me. It's kind of bulky, but I've lost a ton of weight since, they sized me up for the shirt. So thanks, everybody. Hope you enjoyed. We'll catch you later. Ciao. More wine. That is yummy.